So how do we calculate area of a circle? Area of a circle is given here as pi r squared. Area of a circle is given as pi r squared. What do we mean? Pi, this is always given as 22 over 7, or it can be given as 3.14. That is what we call pi. And the r squared, where do we come with the word r? R is a half of diameter. R is a half of diameter, so r is radius. So what is diameter? Diameter is the distance that cut across the circle through the center from one circumference, one part of the circumference to the other part. It goes from the circumference to the circumference through the center, and that is what we call diameter. But a line that runs from circumference and it ends at the center, that line is half the diameter, and that line is what we give the name radius. That line is what we give the name radius. So in short, radius is a half the diameter. So in this case, we say area of a circle is pi r squared. You take pi, you multiply by radius times radius. That was we mean by r squared. Area of a rectangle. Area of a rectangle. We know that a rectangle is a four-sided figure. A rectangle has all the corner angles as 90 degrees. A rectangle is having two pairs of parallel lines. The sum of interior angles of a rectangle add up to 360 degrees. Those are properties of a rectangle. I said a rectangle has four corner angles which are 90 degrees. A rectangle has two pair of parallel lines. The sum of the interior angles are the angles inside, the four corner angles. The sum of the interior angles add up to 360. Most importantly, formula of getting area of a rectangle is length times width. Length times width. Length times width will give us area of a rectangle. The third one that we are going to check here is a square. And a square here, I have it as side squared. Side squared. Why do we have side squared? This is the short form of side times side. This comes about because of the following properties of a rectangle. Number one, all the sides are equal. All the sides are equal. Two pair of parallel lines. Two pair of parallel lines. And when you talk about parallel lines, we know these are lines that do not meet. The lines that will never meet. Number three, the corner angles are 90 degrees, and the sum of the interior angles add up to 360 degrees. And that brings us to the last part, which is formula, which we say is side times side. The short form of side times side is side squared. So far, I've talked all three shapes that we are going to tackle in this area. Shape number one, rectangle. Formula, length times width. That's formula of getting the area. Shape number two, square. Formula of getting area, side times side. Shape number three, circle. How do we get area of a circle? Pi r squared. Pi r squared. Area over circle. Good. And this one will lead us to our next example of shapes that we are going to see. As I mentioned earlier, the first shape we are going to talk about is a cylinder. I said a cylinder is made up of three parts. A cylinder is made up of three parts. We have the top, which is circular in nature. We have the bottom, which is also circular in nature. We can call them sisters. We can call them sisters because they're the same. Then we have the curved part, that part that is curved. Remember, when we open that curve, it always forms a rectangle. And remember, formula for getting area of a rectangle is length times width. In this case, we'll see what we are going to use. Good. So this is the cylinder. This is the curved part I was talking about. This circular part is the curved part, the way it is round. And then this one here is the top. As you can see, it is circular in nature. The shape is a circle. This top is the same as bottom. Bottom is the part that is resting on the ground. That's why we call it bottom, because it is resting on the ground. That's why we call it bottom. So we have top, bottom. They are identical. They are the same. These two shapes are the same. So this one will give us the formula of the area of those two parts. Remember, one of the parts we say pi r squared. That is the area of one circle. Pi r squared. That is area of one circle. But now there are two. We simply add 2. Then we say 2 pi r squared. 2 pi r squared. Then we come to the third part, which is the curved part. This part around here, we call it circumference. And then circumference, when we open it, it will look like a rectangle. So for us to get area of a rectangle, we said earlier it is length times width. So this part here, we'll not call it length at this point. We'll call it circumference. We'll call it circumference. And let us remind ourselves, what is circumference? Circumference is the distance all round a closed figure. Circumference is the distance all round a closed figure. So that part is called circumference. And what is the formula of getting area of circumference? Is pi d. Formula of getting area of circumference is pi d. Formula for circumference is pi d. So in this case, we'll take pi d, we multiply by h. So we say formula of getting circumference is pi d, and circumference, I've said, is the distance all round a closed figure, rather a circular figure. A circular figure, that's circumference. So circumference is pi d, and then we multiply by h, our height. So we have pi d h. In total, we will get the formula of working out a cylinder as 2 pi r squared plus pi d h. 2 pi r squared plus pi d h. Why do we say 2 pi r squared? I explained earlier, two circles. The formula of one circle, pi r squared. Formula of one circle, pi r squared. Now there are 2 pi r squared plus curved part, circumference times height, giving us pi d h pi dh. We'll move to the second shape, and the second shape is a cuboid. A cuboid in our normal daily activities, we always have it. It looks like a box. So a cuboid is a box in short. So in our daily normal activities, we have a box. So that box that you always see at home is a cuboid. So how can we get surface area of that cuboid? When it is closed, means that there is no space anywhere. We'll have two identical parts in each case. So first of all, to get what a cuboid is, number one, it is having 6 faces. A cuboid is having 6 faces. Number two, these 6 faces, we have 2 opposite faces which are all equal. These 2 faces we have opposite which are equal. For the 6 faces we have 2, 2, 2 which are equal, as we are going to see in the diagram. Number 3, all these faces, when we talk of a closed cuboid, all of them are there. No face is missing, so we talk of closed. So look at the first cuboid, which we say it is closed. This part here, this is called top. It's called top. And then down, when it is resting with, we call it bottom. I say bottom is where a shape is resting on. That part we call it bottom. So this part down here is bottom. So which shape are they? They are in rectangular shape. They are in rectangular shape. Earlier on, we said formula of getting area of a rectangle is length times width. Formula of getting area of a rectangle is length times width. So here we have 2 rectangles, top and a bottom. So what do we say? We'll get area of 1, we multiply by 2. So it will be length times width. After getting the answer, multiply by 2. We are going to see how we always put the formula and come to this face facing you, this face facing us. This one here is also in a rectangular shape. As you can see, it is also in a rectangular shape. And this face in rectangular shape is having the other face, this side, the other face, that side, which is the same, exactly the same as the first face. So this faces facing you is also having another one. Which shape is it? A rectangle. It is a rectangle. How do we get area of a rectangle? As said, length times width. How many are they? 2. How many are they? 2. So we'll get the area of one face, we multiply by 2. We come to this face that is facing away from us. This one, we always call them the cross-sectional faces. This face that is not facing us. This face and this face also facing away, this side, they are the same. These 2 faces are the same. They are also in a rectangular shape. So they're in rectangular shape, but from here going up, we call it height. We call it height. And from here going the other side, we call it width. And then this one I did not mention, it is what we call the length. So we have length, width, height. So in this case, instead of, it is in the rectangular shape, it's only that the name here changed to height. Instead of saying length times width, we'll say height times width, height times width, or width times height. And they are 2, and they are 2. So that is all about the faces of a cuboid, a closed cuboid. 6 good faces, each identical faces. We have 2 pairs of identical faces, top and bottom. The face that we said facing us and the face that is facing away from us, those 2 faces are also the same. The cross-sectional faces facing away are also the same. They are also equal. So let's come to the formula of a closed cuboid. We'll say surface area equals to 2 into length times width. That is area of top times 2. 2 into length times width. Area of top times 2 plus area of the other side. This side here we have 2 into length times width. 2 into length times width. Then we have plus 2 into width times height. 2 into width times height. We work out area of this one, length times width times 2, that is area of top and bottom. We come to area of this side, this face, we say length times this one, and then there are 2 multiplied by 2. So I call it width because it is a rectangle in nature. You can see it's a rectangle in nature. Then we come to the last part, we say width times height. This width times this height. And we have the initials as we use. Surface area is equals 2 into length times width plus 2 into length times width, that is for this one, plus 2 into length times height, that is for this one and this one. That is all about a closed cuboid. That is all about a closed cuboid. We say surface area of a closed cuboid, 2 into length times width, close the bracket, plus 2 into length times width, close the bracket, and plus 2 into width times height, close the bracket. And that one will give us the area of a closed cuboid. Let's come to the second type of cuboid, and this is what we call an open cuboid. An open cuboid. Why do we say open? We say open because there is a part which is missing. There is a part which is not there. Take a good example. When you are from outside, you are going to the house, you get it locked. We say the house is not having any space we can go in. And when the door is just open, we'll get through because there is a space. So the same apply to our cuboid. One of the faces has been removed. It is not there completely. So how do we go about this? So one face is missing. Remember, in closed, all the faces were there, and we are using the term 2, 2, 2, 2. 2 into 2 into 2 into. Let's come to the third, to this figure and see. This is the shape. This part here is open. This part here is open. The part is not there. So if the part here is open, yes, the part here is open. The part does it mean we have gone for break? Now we have the second part, and this shape, this shape is now cuboid with this part not there. This upper part is not there. This is the part that I call the top. So the top is missing. If the top is missing, we say it is opened. If the top is missing, we said it is opened. So when we'll be calculating the area, we'll be calculating the area minus one face. So not all the faces are going to be multiplied by 2 because one of the face is missing its twin or its identical face. All right, see, we say the top is not there. So what will be the formula of getting area of top? It will simply be length times width, because it is only the bottom part that is there. It is only the bottom part that is there. So we'll simply say length times width. Right, we come to the next face, which is length times height. Length times height. So length times height, we have this face and the other face this side. So how many faces are there? They are 2 faces. They are 2 faces. Therefore, we'll say 2 into length times height. 2 into length times height. We come to the third face, the face that the cross-sectional face that is away from us, and the face here we have, we'll call this one height, and then we'll call this one width. There are 2, so we say 2 into height times width. 2 into height times width. Those faces are 2. The only face that is missing, is top, and that's why we say open. And I want you to be very keen on this. Always identify the face that is open. It is not a must that it will always be top. Sometimes it can be the cross-section side. Sometimes it can be the face that's facing us. So be very keen on the top that is open. So that top will not multiply by 2. Like in my case here, it is the top that is open. And most people assume it is only the top that is always open. This face can also be missing, and we have top, and we have the remaining parts. So be very keen on checking which face is not there. Now, those are the 2 types of cuboid, and those are the formulas getting area of the cuboid. We've said, number 1, you have a closed cuboid, 2 into length times width plus 2 into length times width. I say that width, you can replace it with height, but remember, you know the measurement and you know what you're writing. Then 2 into length into width times height. That is the formula of a closed cuboid, as you see here and as we discussed earlier. Open cuboid, I've said be very keen on the face that is opened. So after you've realized the face that is open, you'll continue with the formula as it flows. You check, in our case here, it was top. So we say surface area is equals to length times width, bracket, plus 2 into length times width, plus 2 into width times height, because we identified the face that is open and we've used the formula appropriately. Okay, good. This one will take me to the third shape. The third shape, as you can see here, the third shape is a cuboid. The third face is a cuboid. What did we say about a cuboid? 6 sides are equal. All the 6 faces are equal. That is a cuboid. All the lengths are equal. All the lengths are equal. And let's say the faces are identical. So getting surface area of a cuboid is a bit easier. We simply say get area of one face, then multiply by 6 because all the faces are 6. As we can see here, we have face 1, face 2, face 3, face 4 the other side, face 6 on top, and then bottom. All these faces are equal, they are identical, they are the same. So we simply say length times length, because you can decide and call it this side and this is side. They are the same. You can call it length and this is length. They are the same. Even if you say side times side, remember to finally multiply it by 6. Remember finally to multiply it by 6. Even if you say side times side, remember finally to multiply it by 6. Somewhere you will get that the formula is written, like in this case we've used length, it will be written L squared. L squared, then they tell you, they will say L squared like this, then multiply by 6. That simply means that the answer you get after multiplying what is inside the bracket, multiply it by 6. L squared comes from length times length. And as I said, sometimes it can be called side. You say S squared, then multiply by 6. Between the bracket and 6 here, there is a multiplication sign that is always silent. So we normally leave it like that. So these are the 3 of the formulas you can get. Length times length, then we multiply by 6. Length squared, then we open the bracket by multiplying by 6. Side squared, we open the bracket by multiplying by 6. And that's all in area of a surface area of a cuboid. L times L. The answer, the area of one face, multiply by 6. All those faces are the same. So get face of 1, then multiply by 6. And that's all about the formula of a cuboid. And this one will take me through to what is the KCP setting trend of surface area. What is the KCP trend in setting surface area of solids?